In today's lesson, we're going to talk about SE Linux. We're going to discuss what SE Linux is, why we don't just turn it off, and how it also provides least privilege. Problems with traditional discretionary access control, or DAC, we actually have a few problems with it. The first one is administrators cannot control what every user does. So if a user wants to set permissions on their own software or on their own files, they can do that no problem. File permissions and ACLs can't protect you against everything in that case. So read, writes, executes, all those ACLs can be managed by the individual users. Processes can also change the permissions of files or other processes, which may give them elevated privileges. Compromised software may also have access to change permissions within the operating system. So, for example, if you have a compromised SSH process, for example, it might do other things to other parts of the system. SE Linux was first designed by the National Security Agency. It stands for Security Enhanced Linux, and it's Linux answer to mandatory access control, or what we call MAC. So DAC stands for discretionary access control, and MAC stands for mandatory access control. It's built into the Linux kernel as of version 2.6. Primarily, it's used on Red Hat type distributions, but it also can be implemented into other Linux distributions as well. However, later versions of Red Hat, such as CentOS, already have this installed and turned on to enforcing. So Linux, SE Linux breakdown. It's deny by default. It's mandatory access control. So our mandatory access control says, I'm going to deny anything that I don't know. It provides least privilege. So if we change a file, for example, and we modify the ACL on that file, we're only allowed to do what the SE Linux allows us to do, essentially. Another benefit to SE Linux is we log everything. So every change, every allow, we have great troubleshooting tools within SE Linux to figure out what's going on and who has access to what. We can only allow one exception at a time as well. So whenever we make a file change, we have to tell SE Linux, or if it's not allowed, we have to tell SE Linux to look at that file again. We have three different modes with SE Linux. The first one is enforcing, and that one is implementing the mandatory access control on the entire machine. Users cannot bypass it. Everything is logged and everything is denied by default. So the next one is going to be our permissive mode. Our permissive mode says allow everything but log and audit as well. And then our third one is disabled. We don't want to set this at all. We want to make sure that we have at least something that says, here's what things I'm accessing, here's what people are doing to the system. So don't disable SE Linux if it's turned on. So types of enforcement. There are 4 different types of enforcement with SE Linux. The primary control is going to be our type-based enforcement, and that's using targeted policies. Next is role-based access control, and that's based on users. So if a user belongs to a certain group, let's say that they belong to a confidential group, Users of that group may be allowed to access certain confidential marked items. The next is multi-level security, and finally multi-category security. These two types of enforcement aren't used as much, but they provide multiple ways to enforce mandatory access control on processes and files. Okay, they are also used in the targeted policy. Okay, the features and benefits of SE Linux are numerous, but more specifically, three things. The policies are separate from the enforcement. We have great logging enabled, which means that we can understand what users are doing and we can act on enforcement if they're too rigid. Also, we have great troubleshooting tools that allow us to see what's going on, what's allowed and what's not allowed. Controls much of the OS. So SE Linux can manage processes, it can manage files, it can really take control of a system and lock it down to the point that we need to have systems locked down. So think about a bank, for example, a web server, and we need certain access to certain things. Well, what if an attacker decides to break into that server? Mandatory access control could limit the data breach that may happen. The problem with SE Linux are also seen. So mandatory access control takes time to implement. And if you're making many modifications to the operating system, like adding files or adding processes, SE Linux takes time, and you have to allow it for all those exceptions to be made. It is complex. There's a book on SE Linux that's about that thick, 400-page book that says here's all the contexts that we need to think about and change if we're going to be modifying different parts of the operating system. Okay, if you make a change to any part of the file system, you still have to make sure that SE Linux knows about it, because it's mandatory access control. If we don't set permissions on a file or a process, it's not going to be allowed. Typical usage, we've seen this on web servers, we see it on file servers. It's baked into all the newer Red Hat type distributions to provide that mandatory access control to anybody without installing any extra packages. So in conclusion, SE Linux is a very powerful tool, but we need to use it with caution, because it does lock the system down to the point that we need to have high security. However, it is complex. In today's lesson, we'll discuss Linux and security. We're going to discuss what threats Linux has, discuss what items administrators need to be concerned with when dealing with Linux systems, and understand that there's no such thing as a secure computer. Even Linux gets viruses. Okay, so the question I always hear is Linux secure? Well, no computer is ever secure. So computers may be secure at one specific point in time, but it depends on a whole bunch of different things. So it depends on how, where, what software you have on it, a whole bunch of different things to make sure that a computer system is secure. So we can configure Linux in a specific way to make sure that it is secure at one point in time. So if my computer Linux computer is completely off the network and I have all the latest patches, so or it's and it's in a locked room, is it secure? Maybe, maybe not. Depends on what threats that it has against it. So maybe somebody could break in the door. If I don't have a password or the hard drive is not encrypted, I can easily bypass the security of that device and get in. So it doesn't matter if it's on the network or not. It doesn't matter if it's locked in a room. So I need to make sure that I have layers of security protecting my Linux system just as I would any other system. It's no more secure than a Windows system, and it's no more secure than a Mac. Everything gets viruses. Everything has problems with users and configuration, unless I follow very strict guidelines. Okay? Linux can be configured in such a way that you wouldn't have, or you would mitigate a lot of those security vulnerabilities. There are also some pitfalls that we have when dealing with Linux specifically. Okay, the benefits of Linux for security. Linux, because it's open source, we don't see many viruses being developed for it. We see Linux has the tendency to have software installed that has vulnerabilities. But because Linux is open source and has a community of developers around it, the more eyes you have on something, the greater security it has. So the Linux security, or the Linux kernel itself, is pretty secure. There's always something or a vulnerability that may come out here or there, but it's patched relatively quick. In the past year, we have seen, or 2 years, depending on whenever you're viewing this, we've seen Shell Shock, we've seen Ghost, and those have been really serious Linux vulnerabilities that we can exploit. Software typically has less privileges as well within Linux. So Linux processes things with a user and a group as well. So Linux is pretty secure from the standpoint of software execution, unless you increase its privileges. The size of Linux is smaller, meaning that the community, or where Linux is installed in, is smaller. So where Windows, for example, has millions, billions of machines running Windows versions, we may see very little of those machines actually running Linux. And we don't install a lot of software on those Linux machines either, even though they are running a majority of the large enterprise systems across the internet. So how Linux may be compromised. There are 4 different areas that system administrators need to be concerned with when looking at Linux and security. The first one is software vulnerabilities. Second one's going to be configuration errors. Third one is social engineering users in general. And finally, the fourth one is going to be rootkits, viruses, and Trojans. So in the from greatest threat to least threat, let's go through these one by one. Software vulnerabilities. For as long as I can remember, buffer overflows are still the #1 vulnerability out there for software. Developers either forget to sanitize their code for memory leaks, and buffer overflows or buffer underruns may take place. But it's still the #1 thing that plagues everything. So the software that's installed on Linux is not infallible to exploitation of buffer overflows or buffer underruns. So the Linus law states basically, given enough eyeballs, all bugs are shallow, meaning that the more people that you have looking at code and developing that code, the less the less chance you have at major vulnerabilities and those vulnerabilities becoming public. Developers of custom software may not have the luxury of testing software. So software vulnerabilities may be in some of that code that is not used by a lot of people. Software also may not be patched. Linux typically uses package managers to manage the software that's installed on them. However, if we compile Linux code or source code and put those on our systems, install the code from source, we don't get that luxury of those patches unless you recompile that software again. So it's always best to use a package manager to install certain packages, for example, like Debian packages or RPMs, for example. Configuration errors is the second most common type of threat that we see with Linux. Because we are configuring manually a lot of software on Linux, we have a tendency to make mistakes. So a directory, the permissions on that directory may be incorrect, or we may forget to delete a configuration page, which may allow an attacker in, for example. Or perhaps one of the ports that we have for a certain application is left unsecured. For example, port 3306 for MySQL. If we forget to turn that port off or put it behind the firewall, an attacker may get in. It's very easy to do something in Linux, meaning that you can type in rm-rf/*, for example, and delete everything. Linux will let you do that. It's very unforgiving that you can't undo it, unlike Microsoft or Windows, which will not let you delete all your files. So forgetting to do something like that and not have root privileges is also one of those configuration errors that we need to watch out for. Social engineering and users are always a concern no matter what operating system that you are using, no matter if it's Mac, Windows, Sun, doesn't matter. We need to be concerned with social engineering and users because users are the weakest part of any system. Even though it's the job of the system administrator to make sure systems are secure, humans cannot be secure 100% of the time. So if a user leaks their password information out, an attacker may get into that system. This is very evident in one of the more famous cases in the hacktivist group Anonymous several years ago with the HB Gary leaks. This social engineering of the CEO was actually led to their downfall of HB Gary. And Anonymous was at the helm of that. Okay, users make mistakes. Users accidentally delete files. For example, like I said, rm-rf/*. Okay, it's a very easy command to enter. If your users have privileges to do that, then they've just destroyed a system. Amazon and other large corporations have been taken down because of configuration errors and inadvertent commands. So several weeks ago, and depending on when you're viewing this video, maybe months, maybe a year, but Amazon, a third of Amazon was taken down, their AWS platform, because somebody accidentally entered a wrong command when configuring some software. So it took out major companies. Major companies lost millions of dollars of revenue because Amazon was down. Finally, rootkits, viruses, and Trojans. Linux is not as susceptible to rootkits, viruses, and Trojans because of the way that they're built, because of the way the privileges are designed to be least privileges. They're still better than a lot of the other operating systems out there that are less secure. Windows, for example, most Windows users have elevated privileges, for example. Okay, an example of a Linux worm would be the Morris worm back in 1988, which was one of the very first worms for Linux. Okay, Linux also has several different types of ways to mitigate that. So chrootkit, RKHunter, and ClamAV are all open source packages that are designed to keep Linux secure. So in conclusion, administrators need to be diligent about how they are addressing security, and security always needs to be a consideration. While Linux doesn't contract viruses often, we still need to be concerned with configuration errors and software vulnerabilities and make sure our systems are up to date. In this lesson, I will discuss Linux firewalls. There are several software-based firewalls within Linux. Today I'm going to discuss the Ubuntu version called UFW. I'm going to discuss the new firewall within CentOS and Red Hat type systems called Firewall D, and I'm going to show you where we came from. So let's start out with Ubuntu. The two most common software firewalls out there right now are UFW and Firewall D. Now, where we came from was what we called IP Filter. IP Filter is a packet filtering software that can be configured for a variety of different platforms. So we also then had IP Tables, which introduced a stateful firewall rule set into Linux systems. However, IP Filter is still around and can still be manipulated. It's still a loadable kernel module and can be implemented statically within the kernel. However, there have been problems with trying to configure IP Filter and IP Tables. They are very complicated to understand. They have many intricacies that it makes difficult for a normal user to try to configure. So the later firewall versions, UFW and Firewall D, allow us to really easily configure firewalls within our Linux systems. Firewalls are extremely important to understanding where our attacks come from and limiting those attacks. We can also log information that comes in from these attacks. So let's look at Ubuntu first. In Ubuntu, UFW stands for Uncomplicated Firewall. It is enabled and disabled by default on Ubuntu systems, but it also has packages for Debian systems and Arch. It is still a way that we can manage IP tables just with more ease. In order to get the status of what UFW is doing at the moment, we're going to type in UFW status. Status is inactive, so let's enable it. UFW enable. So now it says firewalls active and enable on system startup. So if we type in UFW status again, we'll see that it's active, and let's look at some of the rules. So UFW status verbose. Okay, logging is low, default deny, allow all outgoing, and disabled routed. So if we type in UFW show raw, we can look at the rules that it already has created. Notice this is a huge amount. Let's expand this here. Okay, let's scroll up. Notice how many rules there actually are. This is what iptable looks like if we configure this manually. It's a huge amount of rules. This is what UFW creates when we easily type in an allow or deny port or IP address. And it just keeps on going on and on. Let's say that we want to allow certain services. This is very easy to do, unlike IP tables, which is extremely complicated. We'll type in UFW, allow, 53, and we'll type in the protocol. Port 53 is DNS, so it's going to be UDP, so we're going to type in the protocol UDP. Let's say that we also want to allow SSH. UFW allow SSH. And let's say that we also want to allow communications from a different system. So let's say UFW allow from 192.168.18.131 to any port on port 22. We can also do the exact same thing for denying rules. However, instead of where we say allow, we're going to say deny. So if we wanted to deny port 80, for example, UFW deny 80. Now, let's say that we want to look at these firewall rules again. We're going to type in UFW status numbered. This shows us the status of our firewall and any rules that we have set up. If we look at the firewall rules, the raw firewall rules again for IP tables, it's going to show us a lot more rules than what we currently had. Let's say that we want to look at what we just created. UFW status numbered. Very simply, we have this information. However, let's look to see what changed in the background for IP tables. So UFW show raw, and we're going to grep for port 22. Quite a few more commands, and that's in a lot of different chains, what we call change inside of IP tables. So UFW allows us to not only add services and ports, but it looks at IP addresses as well. Now, UFW still manages IP tables. This is not the case in the new Firewall D for Red Hat type systems. So let's switch over there and let's look at Firewall D. If we type in firewall-cmd state, we'll see that it's running, just like we did on UFW. We also have the concept of zones, which is similar to chains inside IP tables. In order to look at the zones, we can type in firewall-cmd-get-zones. These are our standard zones. The only one that is actually populated, however, is public. If we want to look at services, we can look at firewall-command-get-services. services. There are many different type services, and let's actually list this out here. So it looks like there's 54 words overall. One line, 54 words, 471 characters. Now let's say that I wanted to add a service. In order to add a service, I'm just going to type in firewall -command -zone equals public. And let's say on this server I wanted to add a web server. --add -service equals HTTP. Success. Now within Red Hat type systems, I can still enable IP tables if I want to, if I wanted to get really granular with trying to put a firewall into my system. However, with the new Firewall D, there's no need, and with Firewall D, we're less prone to make mistakes. Firewalls within Linux should always be used to stop services and decrease our attack surface. In this lesson, I will discuss Linux and its services. In this lesson, I will discuss Linux services. Linux services are usually started up on startup to run some kind of process on the system. Software or services that are not used should be disabled to decrease the attack surface of the system. As with any operating system installation, the system is already installed with general packages that may or may not be used. One example of this is Bluetooth. Do you necessarily need Bluetooth on a server? I've never seen Bluetooth used on a server, so that is definitely one that we can disable. Let's look at Linux services. And this is my CentOS system. This is going to be different from Ubuntu and different from some of the other versions. However, mainstream in enterprises, we tend to use CentOS, as I mentioned in previous lessons. In order to see what services we have in startup, we're going to type in checkconfig. We have Net Console, Network, and Splunk. These are different run levels here. So we have run levels 0 through 6, and you'll notice that 0 and 1 are off, and then we have turned on for just the network portion, run levels 2 through 5. Now I added Splunk just to show you what it would look like if that service were running on the server, but I've since turned it off. Now, if I had turned that back on, which I can do real quick, I'm going to type in checkconfig Splunk on. Okay, and let's look at that first command again. I just type in checkconfig, and notice that my run levels again, now they're turned on from 2 to 5. Yeah, but let's turn that off again. So checkconfig Splunk off. And I can do this with other services as well. However, not many services come with checkconfig turned on. In order to see what else is running in the system, by the system account, we're going to type in systemctl. Systemctl gives us what services are currently loaded and running in the kernel. So things like kernel processes. Here's one for printing down below. CUPS is a standard printing service that we may want to disable. Okay, let's look at other things. So Bluetooth, for example, we don't need Bluetooth. These are all, quite a few of these are services that need to be disabled to make sure that we decrease the attack surface of a system. So in order to do that, we're going to disable a couple services here. Notice that there's 152 processes running. So I'm going to type in systemctl and type in status. Let's look at Bluetooth. So here's our Bluetooth. Looks like it's active. And if we type in systemctl status and then the service, we can get a lot more information about what's running in the kernel. So let's turn this off. Systemctl Bluetooth. Whoops. Let's type in systemctl disable Bluetooth. Okay, now let's look to see if it's running. We're going to type in the status again. Okay. It's disabled, but it's still running. So we would have to kill that process. So what I did there is I typed in pkill Bluetooth, which means process kill, and then the process name, which is Bluetooth, and now notice that it's inactive, so it's dead. So I've just turned off Bluetooth, which is probably a good thing for my attack surface. Okay, let's briefly look at a couple more here. And we'll type in systemctl again. As we go through here, it looks like our Splunk service has failed, which is fine because I turned that off. But we can see what's active, what's running, what's inactive. Now, on some servers, especially this server is running a GUI, so I can show you what the command line looks like and some of the other processes very easily. Typically, on an enterprise server, you're not going to have a GUI. Again, it's just another way to increase the attack surface, and it also increases the amount of memory. We need to disable that. The GUI is, in Linux, is called Xserver. So we may want to remove the X Windows system from our server. So we would type in yum group remove and then in quotes X Windows system. That'll just disable that. The other things that we should disable are things that we're not going to use. Things like IPv6. If you don't use IPv6, you should definitely turn that off. The reason why is it's, again, another attack surface. It's a big attack surface if you're not using it. One of the other functions that we're going to look at, one of the other commands, is finding permissions that may be turned on. Some processes need to run with elevated privileges. So think about how you change your password. So PASSWD, for example. I'm root here, but technically that's a root only. Process. So in order for a normal user to access or run PASSWD or some of the other functions, which we'll see here in a second, we need to turn on what we call sticky bits, and that allows the process to run as the system account or root. So what I'm going to do is I'm going to look for those processes that have sticky bits turned on for both the process running as a root or the group root. So in order to do that, I'm going to type in find and where to find it. And let's look at the permissions. So I'm going to put a / parenthesis, then the permission -perm -4000 -o -perm -2000, and then we'll print that out. Okay, so notice all these commands that have our sticky bits turned on. So su or password, group password, sudo. These are processes that you run all the time. And the reason why we have the sticky bit turned on is so that we can run them as root as a normal user. So you should consider disabling some of those. So in order to change or remove the sticky bits, we're going to type in chmod-s and then the file name. So if we wanted to disable locate, for example, which we're not going to do, but let's say that we wanted to do that, we're just going to type in chmod-s and then user sbin and locate. There are some other processes that you may want to consider disabling as well and have been known to be not harmful to disable to the system. And I'll post those as part of your reading for this week. In conclusion, services are a big part of any operating system. However, they increase the attack surface, so consider disabling those services that don't need to be running, such as Bluetooth or your GUI, for example, if this is a server.